Oh, let's see how this goes. This is very different. Some of you may actually remember the last time I did this. Like 18 years ago. Not actually. I did not exist that long ago. Does anyone remember Project Vooperia? Any of you? No? Any chance you'd have to have been here within like the last year? Year and a half? While ago? Okay, so I'm gonna be completely honest, these streams aren't the most exciting, but let me explain the extremely exciting thing we're trying to do today using MS Paint, which is the greatest way to explain it. So, Project Vooperia has been migrated to a octree system. So octrees are fantastic for 3D space, because instead of just having, you know, okay, how can I explain this? But I wish I had a touchscreen on this computer, not just my laptop. Okay, so what we'll do is we'll make this a little bit of a thicker pen so you can't see my mistakes as much. So if we have a chunk, wait, we've got square tool, there we go. We've got a chunk. Normally, in like Minecraft, you will just have another chunk next to it. And those chunks will all be the same size. And that makes things very simple, because if all of your chunks are the same size, then it's very easy to ask, like, what block am I next to? Because then you can be like, well, just look right next to you, man. There's a chunk right there. An octree system works very differently. Because the issue with this is every single chunk has the same exact amount of blocks. And if my player is over here, let's say I'm right here. This is me. I am extremely happy standing over here. Hi, it's Spike. Wow, I'm looking very red today. I'm here. These chunks are close to me, but as I get further away, my perspective gets much bigger, if this is the camera. There is no reason that these chunks need to be as detailed as the chunks near the player, because they're far away. I wouldn't notice if, let's say, every block was twice as big. Well, for blocks it doesn't work very well. Blocks you can tell easily, but if it's smooth terrain, you can't really tell if things further away are less detailed. So that's where an octree system comes into play. Which, instead of having every single chunk be the same size, you have them get larger by a certain degree every distance away. So we start with a chunk of that size, and then every level of detail, we make it double its dimensions. So we'll go from that to that, and then they get big very quickly. But if the player is all the way over here, it doesn't matter that this chunk is so big and undetailed, because by the time you're over here, here's me, a chunk is 16 blocks. So from here to here, we're talking 16 blocks away from the player already. So now we have the detail. So now we have half detail, but now it's another 32 blocks away before we have again, and then it's 64 blocks away, and now we're so far away that it's rolling mountains and stuff in the distance that don't need any detail at all. And then we hit 128. So, here's the thing. This is fantastic because we can use something where blocks, every block on the 128 is about as big as one chunk at 16. So it saves an immense amount of data. We're talking ridiculous amounts of data. Just let's do some basic calculations, and we'll do this in kilobytes, because actually we'll just do it. Let's say every block is just a number that says what type of block it is. So that's 4 bytes. So 4 bytes times 16 times 16 times 16. Each chunk now has 16,000 384 bytes, or if we divide that by 1024, every chunk now needs 16 kilobytes of data to exist. So keep in mind how much RAM your computer has. Planet Earth. Let's say we want to represent planet Earth. So how many meters, if each block is a meter, how many meters wide is Earth? Earth is 12 million meters wide. So let's just get another calculator up. So if we get 12 million, this should be a rather easy calculation. 12 million. And then we cube it. And we're gonna cube it. So we are we are now at this is before multiplying it by 16 kilobytes. So we're at a very large number. Let's go to megabytes. That'll get rid of a few zeros. Yikes. Let's go to gigabytes. Okay, let's go to terabytes. So we only need 25 quintillion terabytes to store all the information on Earth. Fantastic! That's not that bad. Let's just build a new computer. Okay, so let's talk about octrees now. Because octrees half the amount of data we have to use every double distance every time, it actually has a logarithmic cutoff. So I did the math on this in the past. I wrote it down. Let me just quickly find my math, because I was having a lot of fun realizing how fast this was going to be. Here we go. Okay, so an octree can... So we'll even do this in a smaller world. So in a 32 by 32 by 32 chunk world, which is pretty big. This shouldn't be that hard to follow. So if the world is 32 by 32 by 32 chunks, with a normal system without an octree, that's going to be 32,768 chunks. Does anyone want to guess? Actually, let's even do 256 is more impressive. So 256 times 256 times 256 chunks, that's 256 times 16 meters? We're talking a few miles here. An area a few miles in every direction is going to be 65 million chunks. Does anyone want to guess how many chunks we can do it with if it's an octree? Anyone want to guess how many we can get it down to with an octree? Because this is why you can't get an infinite render distance on Minecraft. The number gets really big really fast when you start trying to look very far away. You need a better way to do it. So we go from 65 million chunks required if we use a Minecraft-like chunk system to 361. Now, that is a huge improvement. It is exactly 181,000 times faster. And that, kids, is why you use an octree if you're representing a lot of three-dimensional data. Because you can cut space down into so many little areas instead of millions of them. And you guys want to see how it works? Here's a planet. This is my current working octree system. So this isn't a full-scale planet. I could make it a full-scale planet, but that would be too hard to look at. It would go outside of my view range. This is my octree system as of current. So we can see close to where the player is. The chunks are rather small. But then, when we get further away from the player, the chunks get bigger and less detailed until they hit the lowest level of detail on the very outside. One of these big Mad Lad chunks are going to be about the size of all of the ones near the player. It's absolutely massive, but if you're the player looking from all the way over here, you're never really going to notice that it's less detailed. Also, I know the sphere isn't actually smooth at all. I need to implement better smoothing. But if you're over here, you'll never be able to tell that the chunks further away are less detailed. They just are. So this entire planet is currently... It's got a few chunks because I don't have it unloading or optimizing at all yet. We've got 1,400 chunks loaded. Oh wait, 8,000 isn't right. I think I accidentally changed the number. Okay, point being, the amount of chunks this would use normally is 128 cubed, which would be in the very much high numbers. But we've got it down to 1,387. Let me just quickly grab a calculator. Oh, I have one right there. How much would that be normally? 128 cubed. Yeah, so 2 million gotten down to 1,300. So that's 1,600 times faster. So that's why I've went through this very complicated process of getting octrees working. It is a little bit overkill for a lot of things, but it's necessary if we're going to have entire planets in this game. Which, the entire goal is to make entire planets visible. I want you to be able to look out into the sky and see other planets orbiting your star. So we need insane data compression. And an octree is how we're going to accomplish that. So today, we have a simple job. And now I'm actually going to explain what we're doing today. We are going to get these chunks to be able to recognize what chunks are next to them, which is kind of complicated because before all you had to do, let's say this chunk's name is Fred and this one's Bob. When Bob spawns into the game, he just has to look next to him and say, hey, that's Fred over there. And then Fred just has to say, oh, hey, Bob, how's it going? This is me, Bob. And then they both know each other. The issue is when we get a big boy. When we get a big boy, it gets more complicated. Because when we have a big boy... Now this big boy needs to determine who his neighbor is, and you'll see the issue here. He doesn't have a neighbor. He has two neighbors. How do we handle this? And what about these guys? They're both going to have the same guy as their neighbor. And what block is this compared to the littler block here? That's confusing. Really confusing if you think about it. Thank you for the $2 super chat, Adrian. Let me do that right now, actually. This is going to be painful. Welcome to my Steam friends list. Oh boy, pending invites 160. You are Z done! Fantastic! Great. If you're wondering what music's playing, it's just Monster Cat's best of... Haha, we're gonna be playing that. It's Monster Cat's best of 2018. Okay, so, very fun. We've got our beautiful chunk neighbor system in our head now. Now we have to actually program it out. I have to redo my work from before because it doesn't work anymore with an octree. It wasn't designed for this. So we're gonna have to go into our octree and redesign how it works. Object. I don't like this song. I call a skip. Let's skip. Nope. Still the same song. Okay, that's better. Okay, so this is the fun part. I get to beat up my own code. We have to move the neighbor system from the chunks into... Dude. Yeah... Do the chunks have to be directly responsible for their own neighbors? Or do the octrees have to be? You see, there's so many different ways I could go about it. It's really a matter of, am I going to screw it up horribly and then have to redo it in the future? What are you making? The final goal in Project Vooperia is a massive galaxy-wide team-based, well, faction-based survival game. That sounds very vague, but I could get into details on what it's going to be for hours, but I have to actually get it there. Right now, today, we're going to make a system for chunks to see their neighbor, which is extremely boring. But this stream is more for just relaxing music, going through code, sifting through many bugs, and me having someone to talk to during this journey. I know, so happy. Okay, so what we're going to do is quickly write down what I'm doing here, because I always try to make a little bit of a plan ahead of time so that I can look back and be like, am I actually doing that? Okay, so our octree is storing the neighbor, our chunks storing the neighbors. Let's go through a pro and con list. Pros have octrees holding it. Well, it'd be simpler to find the neighbors because it's literally the octree that holds it. Cons. If the octrees hold it, there's a lot of unnecessary things. I could have the chunk look into its octree to then find neighbor. Oh boy, that may actually be a good solution though. This is in Unity Engine. Okay, I know what I'm gonna do. It's going to be painful though. So we need to make a method in the octree. Oh my god. Okay, so we have a way to get a chunk. And then after we load it, we want to tell every same level of detail neighbor, and then those neighbors tell their... So it's definitely going to have to be done with the octree. That's 1020. So we're talking over 1,000. How many nodes are there compared to how many chunks are there? I think that's a better question, because that'll tell us how much of a performance hit we're gonna take from this. If it's small, then whatever, it's fine. I just want to make sure it's not like absolutely painful, the amount. So there are 435 versus 497. I'll play with those odds. I'll play with them. That's not that bad. That means we're losing about 20% efficiency to get like 50% back. So we're just gonna rip apart the entire system then. This is always fun. You no longer own neighbors, chunks. We're changing how this works. God, I hate... Oh, look at all the red! Look at all the red! Ah! Oh boy, okay, that's all inefficient anyways. I'm gonna rewrite how that works in the first place, so... This is going to be a very long process. Okay, so now that the chunk isn't in charge of that, we're now going to make the octree node in charge of finding their own neighbors. So we're gonna do public, public octree node neighbors holds every neighbor touching, or I guess adjacent is a better way to say it. Holds every neighbor adjacent to this node. So what is a neighbor? A neighbor is just literally anything touching it. And it includes corners. So if we have, let's just draw a little thing here. We've got our chunk. I can't actually see where my cursor is. I hate this. 4K sucks, man. Okay. I can explain it better just in words. If we have chunk, every chunk next to that chunk counts as a neighbor. Simple. Very simple. But we have to make it get those, and that's where it gets unsimple. We have to ask for them. So when this is created, we have to find our neighbors. So here we go. We'll do public void find neighbors. So I know for a fact that I can do this in a few different ways. Oh, I didn't use a vector. I really have to kick myself for some of the decisions I've made in the past. So vector 3i position equals new vector 3i plus x plus y. So we're just putting the position into a vector instead of have it be 3 different numbers, just so that it's easier to work with. So now we run it through every single direction that it could possibly be. So there's 27 different neighbors that each chunk has. Adrian, I did add you. And thank you for the super chat. I did add you though. This is C#. So what we're gonna do is for integer I equals 0, I is less than 26, I plus plus. So for all 27 neighbors, because we're including 0, so the number 0 through 26 is 27 different numbers. We're going to use my helper here. So we're going to do neighbors I equals... And now we have to find the neighbor. So this is the fun part. To find the neighbor, we're going to have to ask the octree itself to look for it. So that's the octree, or is that the parent? Where's the root node? I guess we'll just ask the octree. That makes more sense in the first place. So we'll ask the octree. We'll just say octree.getChunk. Should the neighbors always be the same level of detail? Yes. Yes, they should. So we do neighbors I equals octree.getChunk, and then we're going to send it the direction to vector I plus. This is my little hacky way of doing it in 2 lines of code instead of 80. And then we do that plus position. We could have a slightly cheated way of doing it if we had children already, but I feel like this is going to be much simpler in the long run. Cannot convert chunk to octree node. You see, that's because well, yeah. Yeah, so all we have to really do here is copy our code for getting a chunk. And now instead of get chunk, get node. These are recursive. I need to make sure that it's an octree node though. Okay, get node. If this LOD equals LOD, return this. So we're returning ourself. If it's less, that shouldn't be possible. So we throw an error. Otherwise, get the child if the child's null. Otherwise, return child.getNode. Same thing here, then we return ourselves. Otherwise, we ask it to look further into itself. I'll explain what this does in a second. Okay, simplified version of what this does. I really need something... Okay, let's use Photoshop. You know what? Maybe a little bit overkill. Okay, so, if we are an octree, we are very simple. Octrees aren't that complicated. You just gotta, like, imagine a tree, kind of. It is a tree, but it's a three-dimensional tree. So we've got our square. Here's our square. And here is octreeifying it. This is two-dimensional, so this is a quad tree technically because each one has 4 children. So here's our big boys over here. But what happens if I ask, hey, I want to find the chunk that's here? Well, we start in the biggest one and we ask the biggest one, do you have a child here? And he'll say, yes, I do have a child here. This is my child. And then we ask that one, hey, do you have a child there? And then it goes, yeah, I actually do have a child there. He's here. And then we ask him, hey, do you have a child there? And then he goes, yeah, I do have a child there. And then we ask him and he says, nope, I am the last one. And then we choose him because he is the smallest chunk at that area. Beautiful, I know. What about using one block chunks? That would be extremely inefficient. The reason you group blocks into chunks is because then when something... It uses much less memory. Because we can send things in big chunks of data instead of sending millions of little things. Do you have a child here? Sounds like abducting children. Yeah, talking about octrees is pretty, And the funny thing is getting rid of them is known as killing them, so if I look on Stack Overflow, killing a node's children, programming things, how to kill all child processes on exit, there's some very questionable things. How to kill child processes that spawn their own child process. When you're working with children, you know, you gotta make sure they know their place. And in this case, every child has 8 more children. Or they don't. Okay, so now we should be able to get children of the node. Fantastic. It worked for the chunks, so I'm gonna assume that works. Never assume something works, by the way. But I'm going to. There we go. There we go. Get node... Actually, does not contain a definition for get... Of course you don't, because I never made it so that it does. Let's go to your definition and add that. Instead of get chunk. Oh, jeez. Oh! Wait, why did this bring us back to octree node? I wanted... What? I want the parent. Where is your parent? I want to talk to them immediately. There they are. Okay. So now we go to get chunk and we do some fanciness. Not really. This is actually quite simple. Honestly, it'd make more sense to just ask for the... Okay, you know what? I'm not even going to mess with that. That's fine. Now you can ask for the node and not just the chunk, because I'd assumed that there would be no reason to get the node without the chunk. I mean, the chunk is the only thing the node has. But it turns out that that's all about to change. Okay. So now we just rename a few things. Reuse my code again because it works. Reuse things that work. That's a good thing to do. And you make sure that you're actually returning the correct thing as well, because these should be returning octree nodes. Now, I've asked myself a few times, do I want nodes to be the same thing as chunks? And the answer is no. But damn, would that be simple. It would use way more RAM though, because a lot of nodes don't need a chunk, and chunks use a lot of memory, so making them the same thing would just be a waste. Okay, now we're gonna close this, because you're all done. You should be fine now, you're not complaining. Great. How do I know that you've actually found all your neighbors, though? I don't, do I? That's fun. But I can check on them. You know why I can check on them? Because I can do this little sneaky thing here, and I can make this octree node system.serializable. Watch this. This is the ultimate hack. And now what I can do... Oh, I can't even run the game for like 18 years because I broke literally everything. Okay, let's, Oh boy, I really did mess this up. Ooh, here go several thousand lines of code. Oh, I don't like that. I do not like that at all. Get neighbor from offset has been absolutely murdered. So many methods are now useless. Is there no better way I could do this? No, not really. I even wrote super simple neighbor system, but it's not that simple, I'll be honest. Okay, so killing that part of my code means that I have to rewrite a whole lot of it. So might as well get started. If the octree is now in charge, shoot. Okay, so what we're gonna do is we're going to add a method to chunk to get the chunk neighbor, because that's going to make everything so much simpler for me. I can actually make it kind of normal. Public chunk get neighbor. Great. And we'll do it in direction. So from a direction, returns the chunk neighbor at the specified direction. I think direction is self-explanatory, so I'm not gonna bother. Okay, so we'll do return octree node dot get dot neighbors direction dot chunk. Simple! So simple, and now we just have to change everything to use that instead. So we'll just say get neighbor. And then great. Add a little bit of complexity to it. Uh-oh. Oh wait, this isn't necessary anymore, because this is just completely unnecessary. Okay, how about that, because that's all gonna be handled by the octree now. On neighbor load, called when a neighboring chunk has been loaded. Okay, that's going to also be handled. Although I may want to do something different there in the future, so I'm gonna leave it empty. On neighbor unloaded, again, that's gonna be handled by the octree now. Uh-oh. This is going to be disgusting. Oh boy. This isn't very fun, you see, because there's so much stuff here that I have to redo. On neighbor generated. Yeah, we're just gonna kill all of... Oh, God. Ooh. Oh, boy. Okay, this is where it gets really fun. I'm almost certain I can do this more efficiently, so let's just very quickly... That's a remnant. Okay, so what we'll do... So we need to notify every single neighbor. I've got an idea. Okay. For I equals 0, I is less than 26, I plus plus, all we have to do is neighbors, neighbors, hello? Neighbor, we don't own the neighbors anymore. Shoot. Oh, we can do get neighbor I, and then if it doesn't exist, don't do anything, and then dot on neighbor event, and then we can do the opposite direction. So oh shoot, wait, I'm gonna have to do a little bit of magic here. So we're gonna do negative direction dot direction to vector I, and we're gonna do direction dot vector to we're flip-flopping it real nice. Okay, that's just beautiful. Okay, so that's the direction, and now this chunk, and then neighbor event. Wow! Look at that! We just turned all of this into one line of code. Isn't that just beautiful? I'd say that's pretty beautiful. I should probably explain what this is doing step by step to myself, though. And to you guys. Okay. Great. Oh, I can't put comments. Oh, can I do that? Oh, yes, I can. Okay, so what we're gonna do is we're just gonna say, convert it's simpler in one line, really. Okay. Convert direction to a vector, and then make that negative to find the other way around. Oh my god. Okay. Okay. So, tell a neighbor... How do I write this without breaking my mind? Okay, so what we'll do... Ready? This is gonna be a fun way to explain it. Notify neighbor of event at direction I. We are opposite direction from the other chunk's point of view. So we negate the direction and then convert back into a directional code for it. Good enough. I'll be able to understand that. The thing is, I just have to know what it does. If I know what it does, then it's fine. Okay, great. Now, here, notify neighbors terrain change XYZ. Okay, so this is another one that's pretty simple. We just do get neighbor direction.south instead. Okay. Great. Because now the octree owns the neighbors, so the chunk can't directly call it anymore. We need to use a helper function, which is fine. Slight amounts of speed lost there, but again, we're using an octree, which is like 8 billion times faster, so why the heck not? And I have a little bit of a cheaterson here. All we have to do is highlight all of this, then we can say bam, and we can say neighbors, and we can say replace that with get neighbor. Nice. And that will just make it so that we just have to replace the bracket here. Okay, you know what? This isn't so bad. I mean, my brain is kind of bent by my own code right now, but I've been writing this game for so long, I don't even remember doing like half of it, so it's probably better that I update it. Most people, when they're making a game, they will make it work and then they will worry about making it fast, but that's how you get something like Ark Survival Evolved. So I'm making it fast before I make it work, because stuff like this, once the game is almost like done, it would be almost impossible to change a lower level thing like this. Changing something this low down to the engine would mean having to change pretty much everything in the game at that point. So I'd rather get it perfect now, go through a lot of pain, and you know, but this is gonna be fine. Just a few more parentheses instead of brackets, because we're not indexing anymore. Well, what could possibly go wrong? Okay, beautiful. We've got probably half of the errors gone now. What's going on up here? Is it in game object management? Because that should... Okay, because I was about to say, that shouldn't be having... Oh, terrain management, of course. You do use neighbor... Interesting. You don't actually do it at the higher level. Okay, so mesh render... That's what I expected. Okay, so if we want to iterate through the neighbors, we just have to do get neighbor. Iterating through the neighbors is easy because it literally nothing changes. Bam. Simple fix. Again, here nothing really changes. We just swap that. Why am I doing the same thing twice here? Our terrain. I'm checking something twice here. Is visible. Where am I asking if it's visible? Am I already saying is visible somewhere? Render true if... What? If is surface or... Is this ever being called anywhere? Find all references. Where? Generate mesh. If it's not visible, don't bother making a mesh. But you've already called... Wait, what? Well, you shouldn't render in general if you're not... Okay, we're gonna go back there later because something in that logic just doesn't make sense. But if I change too many things at once, then there's gonna be bugs. So I just want to get the neighbor thing fixed right now. This is not our job anymore. So we can get rid of that. check neighbors. That's not our job anymore. We still have to notify our neighbors of things, but we can assume that they're already all set. Now all the way down here, this isn't very fun. So, get neighbor from offset. Should this belong to that? Yeah, that does make sense. So, this is just gonna have to be swapped out for get neighbor. Oh, shoot, that's a lot. Let's just do it the old-fashioned way. Wait. That was supposed to actually do something. Oh, there we go. Okay. It's very convenient to be able to do mass edits like that instead of rewriting everything by hand. Although a lot of this code was written by hand originally. Copied and pasted a bit of it, but all of these really... Because the thing is, you can make a lazy system to do this in like 5 lines of code. The issue is it's really inefficient compared to just... This only needs 3 if statements no matter what. If I were to make it really simple, it would have taken about 20. I mean, and that's a really small optimization until you realize that this specific thing right here I'm fixing, this gets called over 15 million times a second when a chunk is loading. So, you know, 15 million. Oh no, that's when all the chunks load. That's in total. But that's still a lot. And if you keep speeding things up a tiny bit, it will be good in the long run. And I am also cleaning things up. This specific file has been getting smaller and smaller over time. I've been shrinking my chunk code because I've found faster ways to do it. There we go. But things like this are just a necessary evil. A little bit of nasty logic. Okay, chunk equals neighbor's eye. What is this? Is this unload event? Player chunk move event? Okay, makes sense to me. Chunk e. Thank you, Emerald Kid Gaming, for the $2 super chat. Love the channel. This is C#. This is 100% C#. Okay, so what we're gonna do... The neighbor has don't unload flat... Oh, okay. Yeah. If the neighbor doesn't want it to unload, then don't unload. Because sometimes you can't unload a chunk if the chunk next to it is asking for something. There's a lot of things like that that we have to worry about. But this is getting much simpler. Okay, so the good news is there's no errors! Wow! Ready for this? These 111 errors? They're all gone now. The issue is that nobody's going to know where any neighbors are. Thank you, Potato Warrior, for the €2 super chat. But here's the thing. There's still going to be some issues just because we have to fix things up a bit. We don't have to worry about that anymore because neighbors are no longer handled by chunks. We have to figure out how unloading octrays is gonna... That's gonna be disgusting, but I'll figure it out. Okay, 5 errors left. When the pool wakes up, give it neighbors. Nope, not anymore. Not anymore. Forest, why are you complaining? That's such a random... That's kind of funny, actually. Okay, this is old code. Will you be writing your own shaders? I have written my own shaders already, actually. I wrote a triplanar shader. What's your Discord? My Discord is Spike Viper a hashtag 0001. Okay, so what we're gonna do is... This is such... I'm just gonna comment it out, honestly. This is such old code. It's never going to be used again. Honestly, a lot of classes and stuff here are from back when it was blocky. And the game is no longer blocky, so it doesn't make sense to spend time fixing all of this when, in reality, it doesn't work in the first place. Why fix it when it's gonna be redone? Okay, great. So, if everything is working perfectly fine when we hit play, nothing should be there. But there should also be no errors. Okay, there were errors. That's the less fun version. Object reference not set to an instance of an object. Archinode.name. Oh. Well, that's because I'm an idiot and I never actually initialized this. So when we initialize, we have to create our neighbors. Neighbors equals new Octrinode 26 in length. Great. Now it may still work even with it empty, because technically if they don't have the neighbor, they should just go to the global map. No? Okay, this should be working though, so clearly something's still wrong. Let's see. Did that just not compile? Did I not give it enough time to compile? Okay, so that's an interesting one. Octrinode, our Octrinode isn't null, I know that. So the neighbor, okay, got it. That's nullable. There is a chance that it doesn't have a neighbor there. That's better. Because there's a chance that there is no Octrinode there. Hey! Look at that. So, the good news is everything is working. The bad news is nobody knows who their neighbors are, so this is the least efficient thing ever. We're probably still getting like 1,000 FPS though, because it's just really efficient. Let's check. If we look at our profiler, we're hitting 1,000 FPS. Now my computer is an absolute beast, so that's not saying that much, but 1,000 FPS in a dev build is pretty damn good. Especially considering I haven't even added the part that makes it faster yet. Yeah. Nice. Serialization depth limit 7 exceed. Yeah, that's not even that surprising. Okay, but what we can actually do is if we click on a chunk, we should be able to find its Octrinode. There it is. Nice. And we can see its neighbors. Oh, that was the goal. So, we can actually see its neighbors. That's nice. Okay, I like that. Because now we can see, and look, it can go down. We can look at the neighbor of the neighbor. Okay, that may actually be an issue. It shouldn't be able to... No, that's not recursive. That's just trippy. Okay, so... I'm not worried about graphics FPS right now. I'm worried about the CPU. Everything is running on the CPU. There is no shaders on this or anything. Well, there's just the default ones, so no worries about graphics, because if graphics had an issue, that would be very worrying. I have to make this smooth. I have to write a new smoothing function that isn't this terrible, because this should be like a smooth circle sphere, but you know, I never actually got around to writing a quadratic error function. I use C#. Here we go. So, here's the deal. Now we do the fun part. which the game is working now, which is actually better than I expected. That means I didn't make any mistakes along, well, none that I've noticed. Now what we have to do is we have to go into the Octree node and have it find its neighbors. Now this is fun. Now there's some cheaty things we can do here. We can figure out where we are in our parent, which would make it way faster. You see, the problem is the parent wouldn't be able to do that. I may add an optimization here, but right now let's just do this the simple way. We'll do it the slow way just because it may not even be necessary. I may be looking too far ahead here. This would be easy to fix in the future if I had to. So what we do is we get the node next to us. So we do get node, well, we do for I equals 0, I is less than 26, I plus plus, because we do it for every neighbor. We do neighbors, I equals get node. Please tell me there's a vector 3 override for this. Oh wait, I don't want to get the node from here. I want to do octree dot get node, and that does have an overload, and I want it to be at my own level of detail. So then I'll know. That's actually an issue because I need the one directly next to I know there's something wrong with how I'm about to do this, but I can't put my finger on it, so I'm just gonna do it and wait until a problem arises. Okay. So we'll do direction dot direction to vector I plus my own position, which doesn't exist. So new vector 3i pos x position y position z. And I got cheered, even though I'm not streaming on Twitch. Thanks. Thank you for cheering me. I guess that works. I could just have everyone... You can support me on Twitch while I'm streaming on YouTube. That's not against Twitch guidelines, actually. Good thinking there. That's technically... You see, I can't stream to Twitch if I'm gonna put it on YouTube after. That's against our guidelines if you're an affiliate. You can't do something on Twitch and then post it on YouTube. You have to wait 24 hours first, which I think is ridiculous. But there's no rule against cheering me on Twitch. Go right ahead. Or supporting me on Twitch in any way, really. Thank you, Derpy Dino. Jules doing a bit better. She's on some meds, so her face is calming down a little bit. Okay, so here's the deal. Let's see if the neighbors are actually being gotten, and we do want it to be our specific LOD, so there we go. So first step is first. Oh, I just thought of a really good way to do this. Okay, this is fantastic. And errors. Great. I thought of a good way to do it, and then it died. Hi. Okay. Object reference not set to an instance of an object base. What? You should have a base node, please. Something isn't right here. That should definitely be set to something. Is it the direction I'm doing things in? Base node should be like the first thing set on here. Okay, keep line data, add base node equals new octree node. Oh, the base node shouldn't do it because the base node has no neighbors. Yep, that is correct. The base node is the entire planet. So, if you aren't the root, you do that, because otherwise you've got no neighbors. Great. Fantastic. Let's see if that works. Possibly won't. There are like 4 errors there, so... Hey! No errors! Let's see if it's actually finding its neighbors properly. When you're done on stream, wanna chat? Possibly. It depends how busy I am. Okay, so this is fun. This is fun because now all I have to do, and it does have neighbors, and each neighbor has a chunk. There we go. Okay. We may have just fixed that, but the last thing that has to be done is pretty simple. Okay, we have one thing to do. We go back here. And now when we get our neighbor, we need to tell the neighbor that we are their neighbor. So, this is getting a little bit complicated. Okay, so we'll do public void notify new neighbor, and then we will do vector3i position. Is that gonna be relative or total position? You can do total position and then subtract it. That works. That works. We'll even name it total position so that I don't get confused. Let's node. Oh wait, 3 slashes. Let's a node know that they have been added as a neighbor and allows it to give its children a proper neighbor if they do not have one of the same level of detail. Okay, there we go. That looks good. And now the fun part. So when we get a neighbor, we set it to that. So we'll do octree node neighbor equals that. We want to store it so that we can use it twice. So that equals that. And now we want to do something else. We want to do neighbor dot notify new neighbor. And then we do our position new vector3i position x You know what? We're using this enough that it warrants using a little bit more RAM and just adding public vector3i position and just using that instead. The position of this octree node. Instead of using XYZ, we're just going to use a vector3i, which is going to freak out all of my code. Whatever. This dot position equals new vector3i position x position y position z. It's a little bit uglier to work with sometimes, but now we can just send through position which is so much nicer. Same thing here, we can just do plus position instead. You know. And here as well. We just see, yeah, should have done this a long time ago. Position, although there are some places it gets more. And this, oh wait, I could just add a dot. I named that so beautifully. Okay, look at that. That was pure genius right there. Naming it PuzX because I can just add a dot between the position and the X. That saved me a lot of writing. Okay. This math here was disgusting. And I never want to have to do it again. Okay, so now all we have to do is just add a bunch of dots. Oh no! Okay, wait. We've got to change something here because this is named position. So we'll rename it position code. Okay, so now we can do position.x, position.y, position.z, position.x, position.y, position.z. This is actually going to work out very well for us. We may actually see a slight speed increase from using structs like this. We may see a slight speed decrease, but very slight. I'm not even going to bother figuring out nanoseconds we're speaking here. Not enough for it to ever matter. What matters is readability for this stuff. Now you may see that this is just completely disgusting code over here. Yes, this writing all of this out by hand is not fun. There's some things that just can't be simplified very easily. And this is to figure out where a child node is. Again, sometimes the code just gets really complicated, and you just have to live with it. And that's for rendering where the nodes are. Bam. All done. This currently doesn't do anything, but what we can do is... Okay, so let me explain what we have to do now. Oh, we've got Photoshop open already. Okay. Let's just Control Z everything here. Oh, actually, that was fine what we had. Okay, let's go back to black. Here is our issue. So now this chunk, well, let's say we are this chunk, this happy chunk here. Happy face is us. Now we know that this is our neighbor now. But if we know that this is our neighbor, we know that these two little chunks, which I'm going to outline in blue, these two little chunks are our neighbors as well. How are we going to let them know that? Well, we're going to tell our friend the red chunk that we are to their left, and then the red chunk is going to go, well, I've got two children who are also facing you. And so it's gonna be like, the chunk's gonna notify the other chunk, which will then notify their children. It's a top-down approach to it, but it's gonna work perfectly fine. Did I miss a super chat? 1 second. Oh, IDKY but ban sour cream. I just timed out him. He can't speak for a little bit. Okay. So what we're gonna do now is pretty simple. We're going to no, it's not simple. I'm a liar. Okay. Let's do a little bit of so this is notifying the chunk that we are. So we're the chunk and we're getting this message from our neighbor. So first we do vector 3i position difference equals, and we'll name this actually neighbor position, equals neighbor position minus position. Now we have the vector, that is what direction they're in. We also need the chunk itself. Oh, we could just send the negative position to vector in. That works too. That's actually simpler. Int direction equals... Oh, actually, that's a vector 3i. Vector 3i direction equals that. Very nice. And hello? What? What? Oh, because I named this direction. I see. Why did I make that lowercase? That was really dumb of me. We'll just do vector 3i dir for direction, and then direction plus, okay, and now we do negative direction because it's the opposite. Neighbor direction. So now we have the direction that the neighbor's in, which is great because that means that we can... Okay, we also need to know the neighbor itself. So octree node neighbor. So now we're going to know the neighbor and the direction they're in. So now, okay, this is where it gets interesting. If we have children, how do I check that? If children... If child nodes... Okay, that's no fun, because if we look for it and it's null, then it's gonna create it. I don't want to unnecessarily create it, so is there a way for me to check if I have any children without creating them? I could just make a very quick... Okay, so what we'll do is we will do public bool has children return child nodes equals null, not equal to null. There we go. So if has children, and can we make that a field? And that is a field. I am not going to accept this, I'm sorry, not during stream. Maybe in the future. Don't spam me during my stream, please. This is sad. How do you... Oh, it disappeared. Okay. It's not get wrecked, it's just, you know, if I accepted calls during my streams, then they would get very disorganized very quickly. Okay, so... Uh-oh. Hopefully I've only been on, like, Monster Cat music. I haven't even been paying attention. Whoopsies. Just gonna pray that I didn't just murder my copyright safety. Okay, so what we'll do is pretty simple here. First off, let's make sure that I am safe. Very safe. How about we just go... We'll skip... you know, we'll just do their most popular ones. Why the heck not? Okay. So we're safe again. Fantastic. That's good. Just making sure that I'm not, like, making illegal videos here. Okay, so if we have children, then we have to tell them what direction it's in. All the children are loaded at the same time. So okay. So if we know that we have children, now we have to do the fun part, which is if neighbor direction... Ah! This is gonna suck. This is gonna really suck. Okay. Who do I even... I need to tell the children that they've got... Oh boy, I've got to draw this out, actually. Okay. Okay, so we've got the octree. Let's just make it a little bit more complicated. So he just told the big one here, and now the big one has to tell the two facing it. But this one is also going to have to know that it's diagonally across from it. And this one doesn't have to know. So that means this guy, this guy has to know, this guy has to know, this guy has to know, which means that this is going to be a little bit complicated. Okay. Little bit complicated, but that's okay. You gotta notify your children. So if it has children, but it only has to notify the children it's responsible for. How do we determine which ones are next to it, though? So we've got the direction the neighbor is in. This is going to be rather complicated. Sorry, Adrian, I'm gonna pass on that one. Neighbor direction, neighbor direction, neighbor direction. Well, if you go in the opposite direction, that's the neighbor direction compared to us. Okay, my brain is... I think my brain just jumped off a cliff. Okay, running backwards, we have the chunk, and then we've got its children... Nope, octree node, and then the octree node has its children. Do they even need to be aware of this? Do they need to know? Yes, they do. Okay. So... going to be honest here. This is a brain bender. I need to figure out how to go about this. And the problem is, there's several ways to do it. But the easiest one... Thank you, Adrian. Okay, so if the neighbor direction... How do I determine... How do I even determine this? This is actually... Okay, snowy mapping, you can calm down. You're going into timeout. Okay, so if the chunk just got told that another chunk and then its children are going to have to know that that chunk is... But when those children exist, they should be able to find it themselves. Right? I think so. I don't see why not. They can find the lowest one. I think I'm overcomplicating this, actually. I think I can... I think I can simplify this a whole lot. All I have to do is... do this without the level of detail. But I need it with the level of detail, but I need to say that that's the lowest it can go to. I need to make it more complicated. Because it'll go down... No, that's how the LOD currently works. It'll go down to the LOD, it won't go lower than it. But it will go above it, I believe. Does it return it only at that level of detail or down to that level of detail? Returns. Step down, return no. Oh. Whoops. So what we're gonna do is we're gonna add another way this can work. And then we'll do bool. No, that's right. The one that we're going to... What are we even... Oh boy, okay. So if we're asking for a level of detail, we can mark that as being the lowest. Bool. Treat as min. Okay, so if we treat it as a minimum, that means that that's the lowest it'll go rather than that. So if we do that instead, the difference is going to be we only return null if we're treating it, if we are not treating it as a minimum, then we return null. Otherwise, we just return this because it's the lowest we can go. Okay, that was kind of brain bending, and now it's going to complain inside of the octree because it doesn't know what the heck I'm talking about. So now I'm going to add bool tree as minimum, and we're just gonna pass that through. Oh, here's a drop. Beautiful. Okay, now everything else is going to be broken as well. So we want to treat this as a minimum, not like that's the only thing that can work. And let me explain what I just did. So right now, if we're looking for a chunk, or you guys, well, let me ask, do you guys understand the levels of detail? Do you guys understand the concept? I can re-explain it if you don't, because I do want you guys to be learning how games work. I don't know if... Okay. So what we'll do is show it. So basically, levels of detail is saying chunks will slowly get bigger as they get further away from the player, and they'll become less detailed, which is why it's called levels of detail. So for a player... Oh, well, these aren't really square anymore. I tried. If our player is all the way over here, if this is our player, and they are looking in this direction, this is their field of view, then it makes sense that close to them is smaller chunks which are more detailed, and as it gets further away, it gets less detailed. But what we're currently doing is making a way for chunks to find chunks next to them. And that's where it gets complicated, because if I ask for a chunk like here, I also have to specify what size of chunk I'm looking for, because this chunk obviously is going to have blocks that are like this big, and this chunk's going to have blocks that are like this big, or just terrain in general, not blocks. But this doesn't necessarily translate into that very easily. So basically we're saying, instead of looking for a chunk that's exactly the same size as like this, we're treating it as a minimum. So we're going to say the lowest chunk we're looking for is a LOD2, and then we won't go any lower than that. So if we said, for example, the lowest... Let's do this. If we're saying the lowest LOD we want, so this is LOD 0, this is LOD 1, and this is 2, and if we give ourselves a point here, and we say we want the smallest chunk at an LOD of 1, it's going to be this chunk, because this chunk is at an LOD of 1, and that point is there. If we asked for an LOD of 2 with the same position, it would have been this one. And if we asked for an LOD of 0 at that position, it would have been this one. I hope that makes slightly more sense. It may not. I'm trying. But let's see if that works. Hope being that the neighbor system's working somewhat. And once the neighbor system is working, I can do some more fun stuff. Here we go. So when the octrees break themselves up, it should always have all of its neighbors defined, not divined. Hello? Unity, did you just crash? Uh-oh. I crashed. Hopefully it wasn't because I pulled off some sort of recursion. Oh, yeah, that's a dead. RIP Unity. Let's do a quick restart here. Okay, here we go. This is an interesting one because I'm hoping that we don't crash again. Okay, and will it go? Okay, we're in. We're doing pretty well. Loading the levels of detail. Now we go here, click on it, and it crashes, which means we cannot serialize these anymore because it is getting too recursive way too recursive. That's okay though. Easy fix. Sent you a Steam code in Discord. Merry Christmas. Thank you, David Casey, for the $2 super chat, and for that, I will look out for that and find it. I'll go through my DMs. I've actually been keeping up with my DMs slightly. It's been a uphill battle. Once I clear them out, I get like 50 more. But at least I have plenty of people to talk to. Did anyone notice my fantastic haircut? My hair isn't like down to here anymore. I know. So nice. Maybe one day we can become a programming channel instead of a boring gaming channel. I know. This is so much more exciting. This is quality content right here. Okay. Here we go. Scene. Don't crash. Hey! It didn't. Okay. Very nice. Very nice indeed. So we're going to assume, we're going to make a big assumption here, and we're going to just quickly assume that that's working. I'm joking, I'm not being serious when I said it's boring. Jeez. You guys can't even tell my sarcasm anymore. So you can really see the levels of detail when you're looking from the side. Like, the chunks are so, like, small and simple, and then as you get further away, they get bigger. Now, the big thing is we want to fill in these cracks in between the chunks, and I'm going to make an attempt to do that. This is going to be actually big, because now that technically the thing's working, we can actually try it out. So ready? This is exciting. We go over to Voop Mesher. This is my beautiful meshing code. It's quite complicated, but all we're gonna do is we're gonna go over here, and this, oh yes, very nice. Okay, if this cell has data, if there's a sign change on the edge, God, I have to remember what I was doing here. Okay, this is the fun part. One sec. Gotta just... Okay. Here we go. This is gonna be fun. Down south. Am I actually doing that? Oh. Okay, so this is the moment of truth. This is for if there is... Honestly, I wonder if we should just... Oh, because we have to ask the neighbor. Okay, so the question is, will this work at all? Okay, so if we do chunk.getNeighbor... We're gonna try our best here. This is probably going to fail spectacularly. I don't see how it's actually going to work. If there is no neighbor, it's not going to work. Which is the scary part. What am I thinking? This is not going to work. It's kind of morbid curiosity here. I just want to see if there's any chance whatsoever that it'll work. I mean, if that's just null, that wouldn't be the end of the world. Let's see. If I do that, this may be absolutely... It may just instantly crash. Yep. That's what I expected right off the bat there. Okay, so if... Huh. So we either have to find the maximal edge data... Well, we always have to do that. And the thing is, we have to make it go across different levels of detail, which is also disgusting. But let's just do this one step at a time. We'll say chunk down equals chunk dot get neighbor direction dot down. Chunk south equals that. Then we'll do chunk down south equals that. Because technically that should all work fine. All we have to do is make sure that the neighbor exists. And if the neighbor exists, it should be fine. So if down equals... If down is not equal to null, and south is not equal to null, and down south is not equal to null. Okay, now this is the question. If they exist, then technically there's no reason for this not to work. Well, oh, I have to do down C because chunk. Okay. If down chunk is not equal to null, if south chunk is not equal to null, if down south chunk is not equal to null, down C, down, oh, south C, and then down south C. Bam! Nice. Will it work? No, it shouldn't. Ah! Come on, I was slightly hoping that would slightly work. Okay, where isn't it working? Down C dot maximal. Oh. Oh, shoot, yeah. That is actually an interesting issue. Uh-oh. Spaghetti-o. Can I just technically... You see, that's not good. That is bad. When did that happen? When we were looking for that. Okay. Well, you know what? We pulled off a feat there. We may have a lot more work to do, but we did redo the neighbor system, which is a big step in the right direction, and I needed to do that for a while. So I'm gonna call this a successful stream. I mean, there isn't anything visible that's changed, but code-wise, a lot of things have been set in place that are now ready, so... Whoa! Super exciting! Right? Super duper exciting. And I think that's gonna be it. Okay guys, thank you for watching, and I'm probably going to have to make a normal video, and I will see you all next time. I have a lot more to do though. Peace! Oh boy, there's a lot to do.